Hello everyone, today I want to explain my homework 9.4. Find a block diagram from the single file. Here is the outline of the presentation. We will start with the problem statement. Review the necessary societal background, work through the conversation steps in detail, present the final block diagram, and conclude with a summary. The task is straightforward. Convert the signal flow graph provided in the homework into a block diagram. This involves interfaces or the nodes, blends, and their connections to create a equivalent representation. Before we start conversation, let's review the basics of single flow graph. It consists of nodes which process variable and branches which represent signal transfer with a prefix again. Nodes represent system variable, for example, XS, ES, CS. They are the points where signals are summed or branched. Branches represent single transfer chapters by a gain, for example, GS, HS. The ally indicate the direction of flow. Similarly, a block diagram uses blocks to represent transfer functions and summing tractions, to represent the addition or subtraction of singles. Our goal is to map the elements of the single flow graph to these block diagram elements. Summing traction represent the algebraic summation of multiply input signals, addition or subtractions. As seen in the equation, ES is XS to CS HS. Step 1 is to identify the input and the output nodes. In this graph, we have two inputs. XS is the reference input, and NS is a distribution input. The output is YS. Step 2 is to trace the signal passes. We have a forward pass from XS to YS through GS, a direct pass for the distributes NS, and a feedback pass from CS back to ES with a gain of HS. Step 3 is to construct the block diagram step by step. We start with the GS block, then add the summing traction for the error signal ES. Incorporate the HS feedback and finally and the distributes input NS to the appropriate summary junction. This is the final block diagram. It correctly capture all the elements and connections from the signal flow graph, including two inputs, the feedback loop and the output, providing a clear and equivalent representation of the system. This is the final block diagram. It accurately represents all signal summation and transfer functions. The structure clearly shows the reverse input Xs, distributes input Ns, feedback loop with Hs, and output Ys. In summary, converting a signal flow graph to a block diagram requires careful identification of components and signal passes. The resulting block diagram is a powerful tool for system analysis, clearly showing input, output, and feedback mechanisms. This is all my homework 9.4. Thanks for your listening. See you.